Hello, everybody, and welcome back now to Chapter 6, Computing Components. So, in this lesson, I would start out by using a quote from Winston Churchill, who led Great Britain in World War II. Sir Winston Churchill once said, with respect to the details, that is, he said, "However beautiful the strategy, you should occasionally look at the results. And those results, good or bad, are directly tied to how you handle the details," end quote. And so this week, this is really what we're getting into. We're getting into the details of the computer itself and computer science. So let's go slowly. You may want to review this lesson a couple of times, the lectures or the book or both, and just enjoy it because it's graspable. You'll get there. It may take one or two turns, but you got this. Let's go. So here we go. We'll begin here. So we discussed back in Chapter 1 that the components that are used for input, for processing and output, and storage and communications. Many of those components are shown here on this slide, right? And they're inside the case that contains and protects the electronics. So this week we're going to look inside that case. Now, in addition to this lecture, I will be adding a separate video which will show you a motherboard and a couple of the components on it in real time on a real motherboard. Okay? So, recall that the term system unit, right, is the case that protects a motherboard, the hard drive, the memory, and other electrical components. Some desktops have a tower, right? We call it a tower. And we discussed how some computers were all in one now, right? With the display and the electronics in the same space. Basically, all you see is a computer screen, but the electronics are in that, called an all-in-one. Some of us still have a tower at home encasing the electronics. So you should be familiar, I think, and this is the point of this chapter, with the electronic components inside the case. Again, many of them are shown here for your review. Make some notes if you're unfamiliar with terms we've already covered on this slide. Okay? So, a motherboard now goes by many names. Sometimes it's called a main board, or a main circuit board, or a system board, or a system board book, right? A base board, a planar board, a logic board, etc., right? This is where the main printed circuit board, right? A PCB is a printed circuit board, which is in general use on computers and other expandable systems. So every computer has this printed circuit board, and that's really the motherboard, right? And so it holds and allows communications between many of the crucial electronic components of a system, such as the central processing unit and the memory associated with that. And it provides, this motherboard, the connectors for other peripherals like your mouse, your keyboard, etc. So motherboard usually contains significant subsystems, such as this central processor that I just mentioned, the input and the output, and some of the memory controllers, the interface connectors, and other components for general use. Now, in addition to the motherboard, we want to talk about a computer chip. A computer chip is a small piece of semiconducting material, right? A semiconductor material has this sort of electronic conductivity in it, built in. And so semiconductors are usually made of silicon, in which integrated circuits are etched. So what's an integrated circuit? Well, an integrated circuit contains many of these microscopic pathways capable of carrying electrical current. We're going to talk shortly on how that electrical current is utilized, right? And then I want to mention a transistor. A transistor can act as an electronic switch, right? It'll just open and close, open and close. Today, computer chips contain millions or billions even of transistors that open and close, right? And the chips that we're talking about, these computer chips, they're attached to this circuit board that we know as the motherboard. So these are some of the components from the motherboard. We're going to talk about them throughout the course. Feel free to come back to this and make some additional notes on it. And again, I mentioned I will do a separate video to look at a real motherboard that I hold in my hand and talk about different aspects. Now, the processor, which is also called the central processing unit, and I have that highlighted in red on the bottom right figure in the circle. The CPU, or the central processing unit, this interprets and carries out the basic instructions that operate a computer. The CPU interprets and carries out these instructions. Now, some computer and chip manufacturers use the term microprocessor to refer to this CPU or computer processor chip. Most processor chip manufacturers now even offer multi-core processor. So a multi-core processor is a single chip with two or more separate processor cores. So the processor core, or simply core, right, it contains the circuitry necessary to execute the instructions that we're giving it. The operating system will view, for example, each processor core as its own processor. So a multi-core processor is a single chip with two or more separate processor cores on it. Okay. Now, multi-core processors generally run slower, you should know, and this is covered in the literature, than a single core, but they typically do increase, multi-core processors increase overall performance. The performance increase is especially noticeable if users are running multiple programs simultaneously, like your antivirus in the background, maybe Microsoft Word because you're typing on it, email and browsers, maybe a media player, etc., right? So multi-core processor, very valuable for that. I do that all the time, run all of those. Now, processors contain the control unit and an arithmetic logic unit. A processor has two pieces to it. Remember, your OS, even if you have a multi-core processor, will look at each individually. So let's look then quickly at a processor, right? What's going on inside this CPU? The processors contain a control unit and an arithmetic logic unit. So a processor has two pieces to it. These two components work together to perform the processing operations in your computer. So for every instruction, a processor is going to repeat a set of 4 basic operations, which comprise then what we call a machine cycle, right? So the control unit is the component of the processor that is now going to direct and coordinate most of the operations in your computer, right? Types of internal components that the control unit directs include, as I mentioned, this arithmetic logic unit and registers and buses. We'll talk about those a little bit later. So the ALU, or arithmetic logic unit, is one of those components of the processor, and this is where the arithmetic actions and comparisons are going to take place. Equal than, greater than, or less than, for example, right? It's basic calculations like addition and subtraction, multiplication, division, right? Oh, what I meant was the comparison operations involve determining less than, greater than, or equal to. The arithmetic operations are addition, subtraction, multiplication, and division. And that's really what's going on there. So notice on this slide, you have stuff in storage at the very bottom. And the computer is pulling them out and putting those in memory. Maybe an application on the right side is being pulled out of storage, your hard drive. And then your other You will have other input devices, which are also going to take data or other input and put it into memory. So you've got this data, and you've got these instructions in memory. From memory, the instructions with the data are going to go into the processor control unit at the top of the slide. And that control unit is going to interpret and execute these instructions. Sometimes those instructions require logical calculations. So we use the arithmetic logic unit, or ALU, to do that. And that is going to restore the updated data back into memory on your computer, as shown in this slide. Now, this is really another view of the same, right? And we mentioned this whole process is called a machine cycle. These are the sequential steps for the instructions to execute. So the computer can do many, many machine cycles to process instructions in parallel, right? At the same time is what I mean, right? So these four on the right, fetch, decide, execute, and store, all happening around the CPU, right? Which has those two pieces I just mentioned, the control unit and the arithmetic logic unit, right? So this creates a machine cycle. So for example, you may type onto your computer 100 times 48. And what does that equal? Well, it's going to go to the control unit, which is going to pull up the instructions to execute it. Then it's going to go over to the ALU to do the actual mathematical calculation, which is then going to go back into memory and then display on your screen. It's going to convert it from computer bits and bytes through an ASCII, which is something we'll discuss here in a few slides, so that you can recognize it in human form on your computer screen. So the point is, a machine cycle consists of these steps that a computer processor executes whenever it receives this machine language instruction, right? It's the most basic CPU operation. And modern CPUs are able to perform millions of these machine cycles every second, right? And every second, then, these millions of machine cycles include these steps: fetch, decode, execute, and store, right? So that's, I thought that's a very interesting to understand. Now, a processor contains a register, right? Sometimes it's called a CPU register. This is one of the small set of data holding places that are part of the computer processor. So a register may hold an instruction or a storage address or any kind of data, right? Some sort of bit sequence. Some instructions specify registers as part of the actual instruction itself. So a processor register is quickly accessible. That's the advantage to it. It's an accessible location available to computer processors, and registers usually consist of a small amount of this really fast storage capability. Now, the processor relies on a small quartz crystal circuit called a system clock, and that system clock in the processor is going to control the timing of these operations, and each tick of this clock is called the clock cycle. So the processors are superscalar, which means they can execute more than one instruction per clock cycle. Now here's how it works. The pace of the clock, called the clock speed, is measured by the number of ticks per second. So if your home computer has a clock speed, and it's usually in the gigahertz range, right? So if you have a 3 gigahertz clock speed on your computer, that means you're doing 3 billion, or giga, clock cycles every second or every hertz, right? So last thought, does your clock system keep the track of the current date and time? No, the system clock is to control operations, just like we said. There's a separate battery backed up chip called the real-time clock. That's going to keep track of your date and time. The battery continues to run on that real-time clock even when the computer is off. So they are separate items. Now I'm going to pause there, and then we'll pick it up a little more with the comparison of processors, Intel versus AMD.